Hey guys, Miss Williams here. Hopefully before this one you watched Plate Tectonics. And again, if you had any questions on that one, please email me. If not, we will dive into the plate boundaries. So like on the last PowerPoint, I showed you a picture of the map of all the different plates. So we're going to talk about their boundaries today, so where they touch each other. Because at these boundaries, there's a couple different things that can happen that gives you the different features that we see on our planet today. Again, I have the notes pulled down over here, so if you see me looking over here, I'm not just being weird. I'm trying to make sure I stay on par with the notes for you. So, when two of the plates meet, there are some places on our Earth where more than two plates meet in a spot. Sometimes it's three, but typically we're just going to look at the boundary of two plates. So whenever two plates meet, they can, one, crash together. So whenever they crash together, they either go up like this, and they form mountains. Technically, there's still some stuff down here, so it's like form the mountains, also underneath the ground, but converge, they come together. Diverge means they can move apart, so that's option 2. The plates can just be pulled apart. Or there's a third option, they can slide past each other. So that would be more like this. So that's the 3 options that plates can do. They can come together, pull apart, or go past one another. And you get different things at each of these types of boundaries. So we have convergent, which is coming together, divergent, which is pulling apart, and sliding or transform boundaries, which is going past each other. So that's going to be your first 3 blanks there for the 3 types of boundaries. So the first one that we want to look at more closely is a convergent boundary. So that's whenever our boundaries are coming together. So 2 things can happen. The first, which we've looked at before for seafloor features, is called a subduction zone. So this is whenever we get trenches and things like that. So a subduction zone is whenever one plate is more dense. So let's say this one right here is our oceanic plate. And we know from whenever we studied rocks that the oceanic plate is more dense. And this one can be our continental plate. So whenever those plates come together, the more dense one is going to go underneath the less dense continental plate. So, subduction. When one plate is more dense than another, the more dense plate goes underneath the less dense plate. So, as you can see here in this picture, we've got the oceanic plate going underneath the continental plate. And whenever that happens, the oceanic plate has water and stuff, so as the water comes down here, you will have like bubbles of the water burning off, and that's where you get lava coming up because the water will interact and bring the lava up, and that's how you get features such as volcanoes and hotspots and stuff like that. So, subduction underneath another plate. Those are your blanks right there. Of subduction is whenever one plate is more dense than the other, and then the other one goes underneath. Subduction, one plate goes underneath the other. The features that occur at subduction zones are going to be earthquakes, volcanoes, and ocean trenches, which we've talked about before. So it's just important to know that in a subduction zone, the ocean floor is more dense, and it is going underneath a less dense plate. Let's see. We'll talk about earthquakes more in a couple videos, and also volcanoes. And then again, ocean trenches are some of the deepest parts of the ocean, and they are caused because of these subduction zones. So those are going to be your blanks right there. Now, in your notes, there are sections for you to draw one of these. Clearly, you're not going to be able to draw on your laptop unless you have a fancy laptop. I don't even have one of those, so if you do, that's good for you. But if you want to get out a piece of notebook paper or something like that you can add into your notes so you can look at later, you can sketch and label these just so you can kind of get the general direction at which these are going, because these you have to draw in your project booklet. So just kind of keep that in mind. You don't have to draw in your Word doc notes, but it may help you to sketch it on a piece of notebook paper and label it. So let's move on to the next type of convergent boundary. So Mount St. Helens, this is a feature that is caused by a subduction zone. So it's the Juan de Fuca plate, and it's kind of in the northern Pacific coast of the U.S., is going up underneath the North American plate. So whenever that huge plate starts to become melted by the mantle, all of the water and stuff that was trapped in that rock is being released, and it comes up in the form of magma and lava and creates volcanoes. Let's see here. So the other type of convergent boundary is a collision boundary. So this is whenever two plates of the same material, so let's say two continental plates, they hit and they both buckle. So this is, let's say you play football, and you know that little circle they do where they tackle each other to see, who takes them down. Whenever you get two people matched up that are pretty equally in skill and size, normally they just kind of both hit each other. They don't really, one doesn't fall or anything like that. That's kind of what this means whenever we say these two plates buckle. So what happens is they come together and they're both just as strong as the other, and they just kind of go up. Now, in reality, they're going up and down, but we only see the up portion. So down here on the bottom, this is kind of a little misrepresented because it would be a lot more messy. But the general idea is to know that these two plates are made of the same thing. So one is not necessarily going to go underneath the other. They're just going to kind of both hit each other and go up because of what they're made of the same thing. So they have the same density. So this is kind of what's happening in the Himalayan mountains because they're both the same type of material. They're going up. And we also get earthquakes from this type of convergent boundary because an earthquake is really just the energy coming off of two plates hitting or moving past each other. So you're going to get earthquakes in almost all of these boundaries just because whenever these plates move, it releases energy, especially whenever they crash. So that's kind of what the earthquake is. But the main thing from a collision convergent boundary is that you're going to get mountains. Again, there is a sketch for you to do that. You can do that in your notes or however you feel best. But now we're going to move on to the second type of boundary. So we just talked about two convergent boundaries, one being a subduction and one being a collision. So now we're going to talk about the second type of boundary right after the example because I'm actually really bad at remembering what's in these PowerPoints. So one example, which I've already talked about, is the Himalayas. So this is one of the largest, or not largest, one of the tallest mountains on the Earth's surface. We technically have a taller one that starts underneath the water, but we've already talked about that. So these plates are gliding and they're creating mountains, so they're gaining in elevation. So that's one example of a collision. But now we're going to talk about the second type of boundary, which is a divergent boundary. Hold on. Okay. Divergent boundary. When two plates move apart. So I know a lot of students, whenever I mention these before, they think of Divergent as, the book or the movie series. Nothing to do with this. That's just what came up in my mind. But divergent means to pull apart. So whenever two plates move apart, you get specific types of features. So in continents, you get rift valleys, volcanoes, and earthquakes. So like up in Iceland, I believe, Iceland or Greenland, pretty sure it's Iceland, you have specific types of volcanoes to where the plates are being pulled apart. So then all that magma kind of comes up in these long ridges, and those are a specific type of volcano. And then again, you get earthquakes because the movement of the plates causes an energy release. And then you have a rift valley. I don't think I actually mentioned this before. I could have. But a really good example of a rift valley is over in Africa. So probably 100,000 years or more from now, a large chunk of Africa is actually going to be separated from the main continent because there is a rift valley that's occurring. I will most likely attach a short YouTube video of this just because it's something that's actually pretty cool that's happening geologically now. But that rift valley where the two plates are being pulled apart is going to eventually create a small sea because once it pulls apart far enough, all the water is going to start to drain there. So Africa's literally being ripped apart right now. It's not like in the middle of the continent, but it's still a pretty good chunk of land. The other type of divergent boundary is going to be in the oceans. And we did talk about this because it was one of the main ocean floor features. And this is going to be a mid-ocean ridge. So underneath the ocean, whenever the plates are pulled apart, as that magma rises, it's more quickly cooled because of the water. So then it creates new ocean floor almost immediately. And it keeps doing that, and it keeps doing that, and it keeps doing that. So that's pretty cool. I had some scientists that have studied mid-ocean ridges in their magnetic alignment and all that stuff. But just so you know, divergent boundaries, they can be in both the plates, continental and oceanic. And they have most of the same features. One is just called a mid-ocean ridge because it's under the water, and the other one's a rift valley. So some I've already I actually mentioned both of these already. Africa, this is the Great Rift Valley here. So eventually, this part of Africa is going to be disconnected from the main continent just because of the plates are moving apart because they're a divergent boundary. And then the main one that we talked about in our ocean unit is the Mid-Atlantic Ridge. So this is where the North American plate and the Eurasian plate, maybe? I might have just made that name up. But where these two plates are moving in opposite directions, this is creating new ocean floor. That's what mid-ocean ridges do. They create new ocean floor. So again, here's the Great Rift Valley. So the next type of boundary is going to be called a sliding or transform boundary. So these are kind of cool. We get to study these a lot as geologists. So instead of moving below, so instead of coming together or pulling apart, they're literally just sliding past each other. So the main feature of this is going to be an earthquake because they're not like pushing up or pushing down on each other, just literally kind of like if you're going through a crowd, whenever your shoulders bump other people's shoulders, it creates like a little tussle almost. That's kind of like what these do, but clearly on a much larger scale. So one example is in California, the Pacific Plate slides past the North American Plate, and it's called the San Andreas Fault. So this type of boundary is normally referred to as a fault line, and it basically wreaks havoc for anything that we build next to it. So like roads that are near this, whenever it starts to move, they're destroyed. Clearly you can tell that this fault line has gradually moved this. So these movements can be large scale like this, or it can be over time small scale like this. So like another example, sometimes you'll see like fence posts that are displaced. Those are like over time small scales, but whenever these have big movements, they have big impacts like this. And sometimes these movements will kind of go out into the towns or cities around these faults. And if the buildings aren't made properly, the buildings can be extremely damaged. So that's why whenever we talk about earthquakes, we're going to talk about the Richter scale, because the Richter scale measures the damage caused by earthquakes. So we'll talk more about that whenever we get there. But yeah, so San Andreas Fault is an example of a sliding or transform fault. And yeah, so San Andreas Fault. So here you can kind of see it. It's just literally right there in the open. And I think that's the end of this PowerPoint. If you go on the notes here, there are several pictures that kind of show you what I talked about for each plate boundary. So a couple of them are in color, but they're literally the same pictures I had on the slides, except for one or two of them. We have a kind of a review picture of the seafloor there that we discussed, and you'll be able to identify a lot of these things. So I would look over those pictures at the end of the notes and kind of refresh yourself. Again, for the little sketch sections on your note, I would advise to kind of draw those on a piece of notebook paper because you have to draw those in your booklet. So that's it for the plate boundaries. If y'all have any questions, please email me. And yeah, so this is the last video that you need to do on Monday. I will have the videos ready for the rest of the week as well. But yeah, so hopefully these weren't too confusing and you were able to understand pretty well. If not, like always, email me. Peace out, guys.